Hey everybody, I'm starting a little bit early because I've got some kitty here that's just decided to jump up into my lap, and we're just uh, we're just getting pet a little bit and just chilling a little bit here, pre-show, pre-live stream. So I guess that's kind of not correct because the live stream is going. So, but yeah, just decided to start a little bit early because this guy decided to come up here and say howdy and chew on a couple of fingers and whatnot. So yeah, so hope everybody's doing well out there. Everything's going along here just fine, just fine. Hope everybody's doing well. No, I don't think I want you in that. Okay, so I've shown you their mug, their big mug. Right, this is the kitty mug. So, and if it's not there, or if it's not adequately filled at all times, then there's a crisis, and those get really ugly. Yeah. All right. Well, cool. So yeah, I just sort of decided to press the button on today, and hope everybody's doing well out there. It's been cloudy here the past couple of days, but I do believe that it's supposed to clear up later today. What would be my early morning tomorrow. So we'll see how that goes. If it is going to end up being clear, either early tomorrow morning, right, several hours from now, or if it's going to be clear, the next day or two or three, then I've got to check on some things. I've got some, I'm sort of in this mode with my observing program back here. I'm sort of still in this mode where I'm wanting to try various things, collect data on various objects, various kinds of objects, and then see what kind of measurements I can make and what kind of science I can extract. And so I guess, I mean, what I'm doing now is I'm basically just being like, okay, what are the conditions of the sky going to be, right? If there isn't any moon in the sky, then I probably definitely want to go for some fainter targets, or ones that have a low surface brightness, right? So they might be bright with all the light, from them combined, but because they're extended, they actually have a surface brightness that's a lot less. And if the sky brightness is more or less exactly the same thing as the surface brightness, then you don't see anything. So fainter things like that, right? Basically any extended fuzzy objects, right? Now, does anybody know if anywhere in the sky there are faint fuzzy objects? Yeah, I think we could name at least a couple. So pretty much everything is, right? Except for clusters, right? And even some of the globular clusters, the smaller ones or the fainter ones, are, they resemble, exactly round or spherical galaxies. So they look almost exactly the same as a galaxy, and really, the only way that you're able to differentiate between some of these fainter globular clusters and a galaxy of the same you know, brightness and size is being told that that one's a globular cluster and that one's a galaxy. And that's all you've got. So all right, well, cool. So yeah, I need to start making some decisions. All right, well, Atta is in the chat. I'm really glad to see you again there, Atta. So excellent. Oh, okay. All right. Well, you know, that was a wise move. You know, driving at night is a challenge for anyone, right? Unless you do it a lot, right? I mean, if you do it a lot, you've got a lot of experience, you know. But you know, we're not very nocturnal in a lot of ways, and so you know, driving at night can be a challenge, and you know, I don't like not having choices, right? And when you can't, you know, if you're not allowed to drive at night, then that reduces your choices. Now, technically, I'm not recommending this, right? Technically, if you had to, you could drive at night, right? I mean, you know, it might not be the best thing in the world, but you know, in case of emergency or something, you know, hopefully you still can. So you know, technically, you still do have that choice, right? But you know, if the doctor says, you know, don't do that, well, you know, maybe try to get a second opinion, or you know, search in your heart and see what your heart says, because your heart knows, right? So you know, you just see what your heart thinks, and go with that. So, all right. Let's see. Yes. Well, Atta, that is absolutely true. A narrow band filter will get you a long way. And you've probably researched this a little bit. But before I get into filters, which is going to take us to who knows where, and this train is not going to stop, right? I'm going to put on the brakes. And welcome Bobby on the panel. Hey.
Hey, what's up? Oh, you might want to like bring Jill's cat, Paul DX, in your prayers. They're like evaluating him right now. Last time I checked, and hope and pray he'll be all right.
What happened? Do you have any details?
Paul DX, which many people call Jill's cat.
Right.
He choked on something.
Oh my gosh.
He choked an object, and it got stuck in his throat. So they were checking on him right now.
Okay. You know, I hold cats, as you can probably tell, in very high esteem. I think in a lot of ways they are very, you know, there's a possibility that they are a more advanced species than us. But you know, they have accidents too, so you know, that's okay. Well, here's hoping that they can pull him through that. Don't like, you know, to see anybody or anything under any kind of duress or strain or stress or any kind of problems like that. Yeah, the dumb cat ate something shouldn't have eaten, and yeah, usually that's what dogs do. Dogs, and again, full respect to dog owners, dog lovers. I am one, but they are sort of on the opposite side of the spectrum, um, in a lot of ways in terms of intelligence. Yeah, I don't know about any of this reincarnation stuff, but one of the things I always say is that I hope that if there's such a thing as reincarnation, that I've already been a dog, right? I don't want to be one. Don't want to be one. No, that's just bad news. Bad news. What dogs have to do, or at least think they have to do, is something I'm just not particularly interested in. So that kind of tells me, right, that and I'm sort of saying this tongue in cheek because we have no idea, but if there's a reincarnation thing, I hope that I've already been a dog, and that's sort of why I have no interest in being one now. so all right, well, cool. So yeah, it is going to be clearing up here in the next day. In fact, it's supposed to clear up early tomorrow morning for me. So I'm starting to think about Jupiter observations for tomorrow morning, if there are any events that are going to be going on, and then thinking about doing a session tomorrow, where I'll probably just live stream again, because these two things right now are sort of overlapping, right? We're going to get to a point pretty soon in the next month or so. In fact, that's one of the first things that we can look at here. Let me get that set up. Yeah, I'm ready to go. So this is a really great thing, and it's only good for my location. So sorry, you cannot have this kind of information anywhere else, because the only way to get this kind of information and have it valid for your location is if you are near the MMT in southern Arizona. So the MMT is is now a 6.5 meter reflecting telescope. It's on top of a mountain called Mount Hopkins, which is like just due south of Tucson, maybe I don't know, 30 miles, maybe more, maybe less. I'm not exactly sure. Anyway, and you've seen me show you this before, but I can use the MMT Observatory Observer's Almanac as my reference for sunsets and the various twilights and sunrises and moonrise and moonset. So these times match my time, and of course these are Mountain Standard Time. I'm in Arizona, so we're always on Mountain Standard Time, and as you can see, by the end of the month, right? By the end of the month, astronomical twilight will end at 8:05, right? Local time, PM, right? 20:05, which is 3:05 UTC. So technically, right, I could, at this point, do the live stream for an hour, and abruptly at 3 hours UTC or 8 p.m. and then rush outside and start observing when I should. So so yeah, these two things are still overlapping a little bit. I mean, technically, right? We're into the 27th, 28th of the month. So technically, I'm sort of already there. So, but definitely by April, right? It's going to be long gone, and this actually gets to what about 9:12 p.m. Is sort of my latest astronomical twilight. So that's nice and late. So yeah, what that all means is that at least right now, these two events, the live stream and the opportunity to start observing, are sort of overlapping still. So I'm probably going to do at least a couple more of those, and I don't know if they're necessarily very entertaining or anything. I think even as a participant, it's a little tedious and boring, right? So as an observer, well, yeah, I mean, to each his own. I can definitely do them, so I just will, and it's all about sharing the passion anyway. Looking at some photons and sharing some good astro talk, I'm always up for that. So yeah, so since there's not going to be any moon, I definitely want to be looking at some fainter targets, right? So I did Messier 1 the other night, and I think what I want to do with Messier 1, I was looking at the data that I collected the other night, and it's okay, it's all right, but that supernova remnant was definitely a lot fainter than what I thought it would be. So what I need to do is I need to, I need to collect more data. That's what it comes down to. I can stack all these and get some good signal to noise. It's all about signal to noise, right? When it comes down to it, when you're making a measurement and you want to make it accurately and consistent, then it all comes down to signal to noise. If your signal is very, very strong and your noise is very, very low, then you win. You get the gold star.
So Alta Lenta is saying that is one of the things about being retired. Don't have to worry about working in the way of what I wanted to do.
Mm-hmm. Absolutely. And I've done the other thing, right? I don't really think that I've worked very much at all. Because work is like, things that you have to do, but you'd rather not, right? So, yeah, I've barely done that at all. I've done it, but that's just work, and that's one of those 4-letter words that I avoid. So absolutely. So yeah, and who knows if retirement is going to be an option, for me, or anyone younger than me, right? Don't know if that's going to be an option in the future. So who knows? But we're you know, maybe we'll see this switch to a you know, a non-scarcity society where you know, having to you know, do things that you'd rather not do just to stay alive. That seems a little weird. Um, so yeah, I don't know. I don't know. We'll see how all that goes. So anyway, the plan is to go for some faint objects. I'm thinking galaxies, and I'm thinking galaxies in Leo. Um, so yeah, I'm gonna have to check into that a little bit. The one other thing that I learned from my Messier 1 data that I collected the other day is that I definitely need to make sure. I mean, with the software I've got to make sure that I've got at least 2 stars in the field of view, because I use those stars to register the images before I stack them. So I need at least 2 stars to do that, right? I need one star to stack and 2 stars to rotate. So so yeah, I just need to make sure that I've got 2 stars, and it doesn't particularly matter how faint they are, just as long as they're sort of, you know, bright enough. Signal to noise of, I don't know, 10 or so, that would do. And I think there probably are those kinds of stars. So what I'll have to do is I'll have to, you know, if I choose M65, that's as good as any. You know, the other option is M51, the Whirlpool Galaxy. Yeah, you know what? I might go after that one. I'm going to have to look at the star field for that guy. See what kinds of bright stars are in the field of view or nearby, at least, because you know, I'm making measurements here. I'm not necessarily trying to take pretty pictures. I'm trying to collect data, and so yeah, you know, I'm sort of after a different thing than, you know, the astrophotography crowd. We're both grabbing photons, but I'm measuring their quantities, while, you know, photographers you know, use those photons to make absolutely fantastic pictures, right? So cheers to photons. I'm glad they're around.
I agree.
So I'll tell you, the Messier 65 is pretty darn bright. The brighter, well, you know, I probably need to get a variety as well. So I'll go for some bright objects. I'll go for some faint objects. See how it goes. So yeah, definitely a galaxy, and do, you know, 200 or 300 images, right? At least. So you know, that's going to take about an hour or so. What I need to find out is well, I need to find out about any Jupiter events, right? I'm trying to observe one or more of the Jovian moons move into Jupiter's shadow, right? It's called an eclipse. And this time of year, because of the configuration of the Sun and Jupiter and Earth, we can actually sort of see behind Jupiter a little bit, on the right side, right? So I guess it would be Jupiter's left side if it was facing the sun, right? But from our point of view, it's Jupiter's right side, that we can sort of look around a little bit more. And so what we can actually see is these moons who are seeing the sunlight, right? Well, Jupiter casts a shadow behind it, and from our current point of view over here on the right, we can see those moons actually slip into the shadow. And in the case of Europa and Ganymede and Callisto, we can actually observe them move into the shadow and then out of the shadow again. So we can actually observe the entire occultation if we're willing to wait. This happens fairly often with Io, and a little less often with Europa, and a little less often with Ganymede, and almost never with Callisto. So what I've done is let me grab this. Here. So what I've done, and I think I've posted this site before, and shoot, I don't know if I can remember the site. Let me yeah, it's called Project Pluto. I'm not quite sure why it's called Project Pluto, but they're talking about Jovian events. So I'm just going to post this in the chat, and then you can take a look at it for yourself here.
You might want to check the chat about what Chuck Knackham is saying about Jupiter. Good time to listen to shortwave.
Yes, and there are projects that are doing that.
There are around the 20 megahertz range, Chuck. That's what I keep forgetting.
Yeah, I don't remember either. I think that's about right. 20 to 30 or something like that. It's pretty broadband. Yeah, so Chuck is saying yes. So okay, cool. Yeah, and we've actually looked at that data on this live stream before, and we certainly will again, for sure. Anyway, so let's take a look at this list, and I'll just sort of walk you through it. I think we've probably done this before too, but yeah, I'm going to go for it anyway. So this is just a text file, right? And here, let me zoom in a little bit here. Oh, I found a new way of zooming in with the mouse. Is this going to work? Let's see.
I think it's more of control scroll wheel. I don't think it's going to work on the terminal, though.
I guess it's not. Dang it. All right, here we go. Whoop. Come on. Okay, yeah, it's not working on the terminal. So let's do this a different way. Sorry about that. Let's do it this way.
I think it'd be better off if you use a graphical.
There we go. Okay, so let's go to today, which is the 28th of March, right? In terms of UT, 28 March. So here's what's happening. I'll sort of block this out. So here's what's happening on the 28th of March in terms of Jupiter's 4 Galilean moons and them interacting in some way with Jupiter. So these Roman numerals here can go from 1 to 4, right? And so that's just moons 1 to 4. 1 is Io, 2 is Europa, 3 is Ganymede, and when you see a 4, you know, Callisto moves pretty slowly. Where's the 4? The 4 in here somewhere. Maybe Callisto isn't doing much. There's a 4, okay? Until November. But so that's what this means over here. And then you've got these starts and ends, right? So a TRA is a transit. That's when the moon is passing in front of the planet. Shadow, that's when that moon's shadow is being cast onto the planet. So there must have been a shadow start, yeah, here, right? There's always a shadow start and an end, right? I mean, for every start, there's usually an end. Now, that's not always the case in terms of eclipses, which is what this thing is. So this is an eclipse. This is when Jupiter's shadow passes in front of the moon, right? And then the other thing that we have is an occultation, which is when Jupiter passes in front of the moon, right? So you've got moons that transit, moon's shadows that transit. You've got Jupiter's shadow that eclipses, and Jupiter itself that does an occultation. So those are the 4 kinds of events that you can have for these 4 different moons. And so as you can see, Io has actually already begun its transit, right? Its shadow is already in transit. Actually, it's not anymore, right? That ended 20 minutes ago. The transit of Io itself ends at 3:25, so that's in about an hour. Then at 21:13, Io actually goes behind the shadow of Jupiter, right? So that's an eclipse. These are the things I'm interested in, right? Are the eclipses. So Europa's shadow starts at 21:20. Europa gets eclipsed starting at 22:05. The shadow, or I'm sorry, Ganymede there. The shadow of Europa ends transiting at 23:43, and then Europa itself begins its transit at 23:46. So that's what's happening today. Now this, of course, is all in UT time, so I have to subtract 7 hours from all of these numbers. So in this case, right, these two at least, well, that one would put me at least in the dark. But the problem is that Jupiter hasn't risen yet here. Jupiter these days is rising about 7:30 UTC. So this event is going to take place, and somebody somewhere on the planet could see it, but I'm not. And of course, you know, if there's a UT time like that, well, when I subtract 7 from this, that's 3:05 p.m. in the afternoon. Jupiter has set, and it's the middle of the afternoon. So, you know, the sun is up. So For me, today, nope, I'm not going to see anything at all. So, oh well, that's all right. We can look on the 29th really quick, sort of see what else, see what is going to happen the next day. And again, I'm not really seeing much, right? There's no eclipses anyway, right? So what I've actually done is I've cheated a little bit and already done all the work here. And so these are just the eclipses of EO, right? And my next opportunity is going to actually be April 1st at 10:10 UTC. So that I'm hoping to maybe see. We will see. There's a couple other opportunities in April too, right? One on the 17th, one on the 24th. So that'll be nice. Here's Europa. Europa eclipse. You can see for March, there was just that one on the 16th, which I got clouded out on. There's going to be a pretty nice one here at 7:54. Problem is that, you know, Jupiter is going to be rising, what, somewhere around like maybe 5 after 7 or so. So it'll not have even been up for an hour yet. So it's going to be really, really low on the horizon. But I'm definitely going to go for that one, and hopefully the one on the 17th as well. This is a great opportunity.
So this is either UTC or your local time.
This is UTC. This is all UTC. Yeah.
So every month, the Jupiter rising time changes, right?
Right. It changes, as you can see. It changes by a couple hours. Right. And that makes sense because, you know, in a 24-hour day, 24 hours of right ascension, right, all the way around, 12 months. So every month changes by 2 hours. 12 months, 2 hours a month, 24 hours. So that's how that works. So yeah, so there's a couple opportunities in April, right? But nothing here. You know, there are events taking place, right? But I can't always see them. Jupiter has to actually be up. So there's Europa. I've got Ganymede on here too. So there is that eclipse, you know, that we saw, but it is taking place at 22:05. I can't see that one. This one I'll be able to see though on April 19th. So I'm kind of interested in that.
So out of my curiosity, how did you get this information?
Well, that is at a site that I posted onto the chat room. So take a look over there. I was aware that this kind of information existed. So I think originally I just did some kind of Google search and got this list, right? I got this. Oh, in fact, here, I'll show it to you. I've got it. Do I have it here? Yeah. Okay, so here's this site, all right, that I posted. That I posted to the chat, right? And here's the list. So I just copied and pasted this thing, right, into a text file, and that's what we've been looking at. It's indexed by month too, so that's kind of nice. So yeah, that's how I found I found that, and you know, that is one of the things that I want to do. Is I want to you know, observe these events and time them, right? Is this, you know, hopefully, um, when I observe this event on um, April 19th, it will take place at that time, right? And if it doesn't take place at that time, right, if it's significantly one way or another, well, I'd like to understand why, right? It, you know, is there something wrong with my clock? Is there something wrong with this prediction? You know, I don't know. So you know, that's one of the things, is to see, you know, how close the prediction is. So we will see. We will see. That's kind of a fun thing. But for the next several days, I'm not seeing any Jupiter events at all. So, you know, sad to have to report. I'm not going to have to get up at 3 a.m. to make those kinds of observations. I'm devastated by that, but oh well. So yeah, I think that's what's going on with all of that. I'm going to I haven't had a chance to look at any of the other data yet. The Pallas data, you know, the asteroid Pallas. I got about not very much on that. I think I got like 20 minutes of data on that. You do see a little bit of motion, so that's nice. But I haven't really done much with that yet, and I haven't done much of anything with R Leo yet either. And probably, like I said before, with R Leo, I think I definitely just have to have that star on my observing list every single time, because it's a long period variable star, and so, you know, I'm not going to observe any variability over the course of even one whole night, right? I'm not going to see things change very much. But if I observe this thing, you know, once a week, or, you know, whatever the schedule is, however the weather behaves, then, you know, over the course of the next year or so, I should definitely get a nice light curve. And, you know, after that, I sort of have to decide what I want to do with that. But for now, it's just, it's, you know, convincing me more than anything else that you know, this system is capable of doing some pretty reasonable science, right? I mean, if it's asked, it can deliver the kind of data that scientists would want to have in order to do their work, right? So that's sort of what I'm testing, are the capabilities of this system. So yeah, I think definitely M1, definitely like M65 or something over there. It doesn't have to be M65. That's actually getting a little bit high in the sky. So I might go for something a little lower in the sky, you know, so I can have more time to observe it. I like to sit on that for a couple hours at least. Get lots and lots of data on that. So, and R Leo, and
I think your kitten over was out.
I think so. I think so. Well, maybe he'll want to come up here just for a second. No? Yes? Okay, there he is again.
Oh, there he goes.
There he goes. Yeah, he was up here earlier,
And I started a little bit early because he was here and he was saying, "Come on, just push the button, dude." Right?
Yeah. I was just getting done with my shortwave show.
Cool. Excellent.
And then I had to reboot the computer because it wasn't communicating with the internet thing.
That's no good.
A simple reboot fixed that.
Well, you know, like I always say, I wish that I had a reset button or some kind of reboot thing, because rebooting takes care of all kinds of things, right? Cleans everything out. So, you know, where's my button, right? I want one. And why don't we have one?
I know.
I want one of those. I'll pay good money too. I don't have any, but I'll pay it. All right. Well, excellent. I think, you know, there was kind of an interesting, you know what? Let me let this guy out, right? I am the servant here, right? As I said, these are highly evolved creatures, right? They have figured out that you know, they don't need to do anything at all. They just let us joyfully do it. So, all right, I'll be right back. All right, here we go. There we are. So I think it was a tweet. I think I saw a tweet from, I don't even know who it was, but so the OSIRIS-REx spacecraft is currently in very, very close proximity to the asteroid Bennu, right? And OSIRIS-REx is, I guess, I mean, it has a lot of other instrumentation, but one of its primary goals is a sample return, right? So they arrived at Bennu several months ago, right? And what they've essentially been doing ever since is mapping this asteroid very, very carefully, right? Because they're looking for a place to grab some dirt, right? And that's what they're going to be doing. They're going to be grabbing some dirt. Now, you know, I don't know if grabbing dirt is such a great accomplishment, but I guess you have to consider the minor fact that it's an asteroid millions and millions of kilometers away. Okay, so it's a little special dirt. So I just think it's funny that you know, they're really, really excited about going and grabbing a bunch of dirt. So I think that is great, though, right? And you know, we're definitely going to learn a lot, and I hope that there will be lots of surprises, and I hope it's a success, right? But what they're doing right now is they are photographing the surface. I think they have, I forget what the instrumentation on it is, but I would think that they would have like magnetometers, accelerometers. You know, they have at least one imager. I think they might have more than one. They might even have some spectrographs. I'm not exactly sure, right? But so, you know, their primary thing is to figure out where you know, to go down and actually grab some dirt. And so they're in the process of working on that now, and they they have come across their first surprise, which, you know, I absolutely love surprises, right? I think they're absolutely great. So here's a surprise. Surprise is that stuff is flying off of Bennu. Dust and rocks and everything seem to be I forget what term was actually used, but it's like being sprayed, right? This dirt and stuff and rocks are being sprayed off of Bennu. And I haven't looked carefully at the picture yet, and I probably should. It's okay. Yes, we all wish that we had a reboot button. You know, I don't know why this thing didn't come with one. I mean, everything else, I guess, not everything else does, but I don't know. Hey, there's Austin. Hope everybody's doing well. Gabriel, nice to see you in the chat. Excellent. All right, well, we're talking astronomy here, so let's keep going with that at least. So OSIRIS-REx is at Bennu, and they've observed this spray, right? And so somebody,
please consider using the English language. You will be banned if you don't.
Yeah, we have to do English here. We definitely do. That's the only way I'm going to be able to understand anything. I'm barely good at that, as you can probably tell. So yeah. Cool. All right, I don't know what that is. All right, very, very cool. So somebody has taken that information, that spray out data, and they have written a short little thing to the research notes of the American Astronomical Society, talking about meteors that come from this asteroid, right? Meteors that we can see here on Earth. And I was trying to understand the article because it's and maybe we can look at it here, and I can embarrass myself even more. That's always an enjoyable thing. And try to understand what they're talking about a little bit more, and we can just do that live. So let's see. I'm going to go over. In fact, I'm already over at the proper website. So I'm going to share my screen. Go to infinity. Wow. And here we are. Actually, you know, I remember who tweeted this. It was the author. I saw the author's tweet saying, "Hey, I just published this over on RNAS." So, prediction of meteor activities from 101.955 Bennu. So the OSIRIS-REx spacecraft, right? Now, you know, it's not really orbiting Bennu, right? It's orbiting the sun, and just is in the proximity of Bennu, feeling a little bit of Bennu, right? but not enough to stick around. So yeah, orbiting, that's not necessarily incorrect, but it's not exactly correct either. Anyway, as it says here, it has detected dust emission from the asteroids, from this asteroid, and emission from these kinds of asteroids and comets.
Before you continue, I just got something from Jill's. Paul the cat is going to be all right.
Yay! Yeah. Well, I was hoping so. So good. Good. Dumb cat. Jeez. So what they did here in this paper, right, is they present a preliminary calculation of the encounters between the recent ejecta from Bennu and Earth, right? So they are predicting meteors that are coming from Bennu, and when they should happen, I think, where they should appear to be coming from, right? They're radiant in the sky, and maybe how many, right? Ejecta released after 1500. So this is where I started getting a little bit confused. I think that's the year 1500. And I guess I'm sort of wondering, how do we know that it was ejecting material in 1500? What do you base that on? If I'm reading that right, they need to have some kind of unit here, like 8 AD or something, right? Because this is a little confusing, right? What does 1500 mean? But I think it's a date. I think it's a year. So they trace the orbit of Bennu back into 1500, and then they run it forward to 2100, with particles ejected at every perihelion. So okay, so all right, so that's exactly what they're doing. They are running this asteroid in its current orbit, right, from the year 1500 to the year 2100, and they are saying that it's ejecting particles at every perihelion. So, of course, perihelion is when it's closest to the sun. So then all the, those particles get ejected and then are subject to other perturbations caused by the major planets, right? And some solar effects, right? Radiative effects. Make some assumptions, right? Production rate to be 0.15 kilograms per second. Okay, which is as much as they've seen so far. So here they are. So encounters between 1900 and 2100 are summarized in Table 1. So I'm a little confused
about this too, because, and maybe we need to look somewhere else, but this says that the encounters between 1900 and 2100 are summarized in Table 1. Well, there's like one in 1991, nothing before that, and nothing until 2014, and all of a sudden you get one like every year. So I'm a little confused. I would think that this would happen every year, right? Because the Earth is orbiting the sun every year. And you see the date, right? The time changes, but the date, look at that. It's always September 24th. Here's a 25th one. September 24th.
And what object they're putting models on?
This is the asteroid Bennu, which has been observed now spewing out stuff, right, at about 0.15 kilograms per second. But I'm a little confused about this table, because this says that's between 1900 and 2100. So why is this one here, right? Why is 1991 there? Why isn't 1900 there? Why isn't 1960 there? And then why is there this big gap here? So yeah, I'm just not quite sure what's going on.
Yeah, that's crazy.
Yeah, it's just a little, it's confusing, right? And I don't think that there's, I mean, references. I'm trying to see if this, yeah, I'm confused. I'm a little confused about all of that. But anyway, it's kind of interesting. You know, they worked out that the meteors from Bennu will come from about this location in the sky, right? And have that kind of speed, right? 6 kilometers a second, which I don't know if that's fast or slow. I would think that that's pretty slow. I think that's kind of slow. And that would make sense, right? Because, you know, the orbit of Bennu and the orbit of the Earth are relatively close to one another, right? So their orbital speeds are going to be about the same. So their relative speeds are going to be pretty small. So what they're saying here is that a very slow entry speed means that a 1 centimeter meteoroid will only produce a +6 magnitude meteor, right? So this must be really, really slow, right? Really, really slow. Because typically, if you have a meteoroid that's the size of a marble, right? That is going to make a very, very, very bright meteor, very bright. But I guess because they're moving so much slower, they don't produce the energy, they don't emit as much light, and there you go.
Now, this is in kilometers per second, right?
Correct.
Well,
Let's see.
it's actually moving about in miles per hour, 13,421.6 miles per hour.
Yeah, see, that's not very fast. That's not very fast at all. Let's look at the Perseid meteor shower and see if we can.
What was the next one?
And let's see if we can see what their velocity is. Look at that. 58 kilometers a second, 10 times faster.
So yeah, these things are moving incredibly slow, right? Incredibly slow. So when they hit the atmosphere of the Earth, you know, even though that is, yes, that is fast, but relatively speaking, it's not. And so a small object like a marble coming in, right, is going to get very, very hot, right? But it's really small. So,
I guess
so yeah.
the crazy thing about it is we move fast, but in interstellar wise, we're not moving fast. Is that
not? That's exactly right. Yeah, we're, you know, I mean, it depends on your perspective, right? I mean, you know, to us, 6 kilometers a second, yeah, that is really fast, right? That's really, really fast. But in terms of planetary speeds, no, that's nothing. That's absolutely nothing. So yeah, kind of interesting. As I said, I'm really confused about this table, because if this is supposed to be between 1900 and 2100, where's all the other ones? I'm confused. And I think these dates, I think these are also dates. This is when for this event, right? So for this, if you want to call it meteor shower, I think what this is saying is that the particles were thrown off of Bennu somewhere between these dates, right? So between 1508 and 1850, the particles that are going to be smashing into the Earth.
so? Wait a minute. That 1508 to 1850. That's not UTC. It's something else.
No, that's a year. I think that's a year, right? So like 1508 AD to 1850 AD, right? So that's when the particles that are going to be smashing into the Earth on September 25th, 2022, that's when these particles actually were spewed off of Bennu, right? So, you know, several hundred years ago. And here's yeah, you know, it's a really interesting model. I mean, this has got to be either an undergraduate student or a graduate student doing this. That's my only guess. Because yeah, it's, you know, it's good practice working, you know, with models and with software, right? And that's exactly what this is, right? It's a meteoroid dynamics model, and so that's really the exercise here, right? Is to work with the model, because models are hard, right? They are hard. Not only, you know, the models themselves, but the code, right? This is all software.
I'd like to know what Chuck Nagwam means about copy and paste job.
I don't know. I don't know. Chuck, you have to elaborate. So yeah, as I said, I think this is kind of interesting, right? And I think it's really, really cool, but it looks incomplete, at least as far as the table goes.
Yeah, he was talking about that table about Bennu.
Oh, okay. Let me see what he's talking about. Okay, gotcha. All right. Well, anyway, I thought that was kind of interesting, and I wanted to investigate that a little bit more, see if I could understand it a little bit better. And
Could
you
it be
know,
a
I think,
foreign exchange student that did something like that?
well, that's exactly what I was going, you know, to point out. But you know, the problem that is there with that paper isn't a language problem. So you know, the only other thing I can think, right, is that either that's a typo, you know, the range, or you know, they had these research notes are I think strictly enforced, limited to 1,000 words, right? And I think like one table or one plot. So you know, maybe they had to limit their size of their table, and you know, they couldn't do 200 years worth of eclipses or of meteor showers, right? So he just sort of arbitrarily chose 1991, and then arbitrarily started with 2014. Don't know why. Don't know why. Might, you know, that might be a question to ask the author, right? Their emails are almost always on here. There it is.
I agree. Emailing the authors.
All right. Well, you know, on behalf of Astronomy Daily Live, I will do that, and I will report back. I'll show you the response I get, if I get any response at all. Now, most people are thrilled that somebody is reading their paper, so I expect a response. But yes, I will send this author an email with my questions, and if and when I get a response, I will share it with all of you, verbatim, the whole thing. You'll even be able to see what I wrote. So yeah, I think that'll be a little bit fun, and you know, if you have questions when you're reading any kind of paper or article or anything, you know, if the author supplies an email or some kind of contact information, you have a question, ask, right? Don't feel as though you're asking a dumb question, or you know, they're not going to you know, give you the time of day. They may not, right? But in my experience, every single time I've emailed an author, I always get them saying, I think it's really, really cool that you read my paper. So first I want to say that, right? And then, you know, they try to answer the question, right? So I'll do exactly the same thing. And if he responds, I will show it to you. Yeah. Very cool. All right. Well, I think with that, I'm going to get out of here for now. I'm just going to check the chat one more time. Mystery science. Yeah. Well, you know, there are a lot of mysteries out there, and science is one way, one tool of getting at them. Is it the only tool? Is it the best tool? I don't know. I don't know. Maybe we're going down a dark alley, right? And it's going to end, right? And then who knows, right? There, you know, maybe the process of science isn't the way to look at things. Don't know. Don't know. It's, you know, it seems pretty satisfying. It seems to work pretty well. I think we're too early in the game to really know for sure, right?
you know, if this is a blind alley, we've just started sort of moving down that blind alley. So you know, if it is a blind alley, you know, hopefully we'll be able to realize it sooner than later. But no, you know, I mean, it's worked for a while, and it seems to work pretty well. So we'll see. We'll see. In the end may be nigh. You never know. You never know. You know, there are revolutions and paradigm shifts. So you never know. You never know. All right, everybody. Well, take care. I'm going to get out of here for now. So thanks for coming in once again. So make sure to subscribe if you haven't already. Have a great evening, a great day. Hit the thumbs up if you so desire. Make some comments. Spread the word, right? I'm here just sharing a passion, just having fun. Don't have any, you know, necessarily any goals or plans for this channel, except to always try to get better and better and better, whatever that means, and try to keep finding this kind of crowd. I've got a really great group here, and I should say we have a really great group here, and yeah, I think it's great fun, and let's do it again in about well, definitely in a little less than 23 hours from now. Yeah, I think I'll do this again. Sounds good. How about 2 hours UTC? Sounds good? Okay, let's do it again. All right.
Live long and prosper.
Take care, everybody. Live long and prosper. Actually, Tom noted in the Discord yesterday that Leonard Nimoy's birthday was yesterday. So, yes, very cool. All right, everybody. Take care. I will see you on the spin. See you later. Bye.